Graphs, the art of presenting data. In the Information for Authors page of every issue of the Journal of Speech, Language, and Hearing Research states, tables, titles, and figure captions should be concise but explanatory. The reader should not have to refer to the text to decipher the information. Good tables and figures should stand on their own. Tables and figures should show the data, be brief but informative, induce the reader to think about the data being presented rather than some other aspect of the graph, so it should be clear. They should avoid distorting the data, stay away from 3D charts. They should present many numbers with minimum ink, so make it clear. They should make large data sets, assuming you have one, coherent, and encourage the reader to compare different pieces of the data. Common tabular and graphs. To show the frequency of an observation for nominal and ordinal data, you could use a frequency table, a histogram, a polygon, or a cumulative frequency distribution. To display interval and ratio data, there are line graphs and scatter plots. Table 7.1, hypothetical example of the conversion of raw scores into a frequency and cumulative frequency table. So A, we have a histogram, and B, we have a frequency polygon of scores. Both very clear. Frequency and cumulative frequency table, and then a cumulative frequency distribution. Again, both figures are very clear. This is for our nominal data, or ordinal. Tables. Box-and-Wiskers plots. These are good for reporting descriptive statistics. A histogram. A line graph when we're doing our interval and linear data. And a scatter plot. Misleading graphs. Things to consider when making a graph. The title, labels on both axes of a line or a bar chart and on all sections of a pie chart. The source of the data, the key to the pictograph, uniform size of symbols and pictograph, scale. Does it start with a 0? If not, is there a breakdown shown? Scales. Are the numbers equally spaced? Is this a good graph? No, it is not. It is confusing and misleading. Why is this a better graph? You can clearly see the effects of the thoughts and actions with treatment or no treatment. What's deceiving about these figures? In the top figure, you see it starts at 0 and then goes up to 6. To the right, the blue bar graph starts at 4 and goes up to 6. The difference looks much greater between 4 and 6 than when you compare it to the graph on the left that starts at 0. Same thing for the two lower figures. Notice on the y-axis, the first value you see is 80,000 pounds, and it shows a difference between 80 and 82,000 pounds. It looks like a massive increase in housing prices, but the same data on a figure that starts at 0, you could see there's not much of a difference. What's confusing about this? Look at the y-axis. 0, 1, 2, 4, 8, 16. What's that? Shouldn't it be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 0, 2, 4, 6, 8? It's not consistent. What about this figure? The number of singles sold, 1995 through 1998. while there's no value on the y-axis. And again, you can't see it clearly. You can't see the difference, or in fact that there was no difference between 1995 and 1997. College enrollment figures. Look to the y-axis. Do you see it's kind of zoomed in on the left, and it looks like a much bigger difference than it is on the right. So figures can be deceiving. Make sure you look at them closely to interpret them.